Hello and welcome to the Obscast. My name is Joe Gathercole and this is your November edition. Coming up later, I will be talking to the Obscast's resident astronomer Steve Smith about what we should be looking up at and looking forward to for the rest of November. But before we get round to that, we spoke about NASA's DART mission. If you're anything like me, throwing a dart at a target usually results in a hole in the surrounding wall. The idea of that dartboard being millions of kilometers away and the dart being thrown by a rocket using orbital mechanics to hit an extra dartboard orbiting the original one, well, it sounds like I'd need lots more practice, but luckily for us, NASA has been doing this sort of thing for a while, and their mission, called DART, was sent to redirect an asteroid. Was it a successful mission or not? Well, that's just one aspect of the mission we talked about. So Steve, welcome back to the Obscast. How are you doing?
I'm doing really good, thanks. Thanks for asking me back.
That's right.
I'm looking forward to this one. I was a bit nervous on the first one. I'm not quite sure what, with the new technology, what to expect, but I'm a little bit more relaxed tonight. So I hope that comes through a bit better.
I didn't even notice you were nervous last time, so it's fine. So we're here to talk about the DART mission first. Is this something that's piqued your interest, or is it something you've been following?
Yeah, very exciting stuff. Well, I've been reading about it in the magazines, which are a little bit behind the news. In this month's Astronomy Now magazine, there is a report, but the report is out of date because we now know the results of the test. But it's been interesting because it's quite an interesting mission because it's something that could save large swathes of humanity on our planet from a future collision with an asteroid, and so it's nice to see something is happening with regard to the safety of the planet. So I think it will be interesting to say what was DART and what was its mission and how it was accomplished. So yeah, I think I have been following it. Yes.
Yeah, like it's the first step into planetary defense, and also it's the first time something like this has been done. We should say DART is an acronym for the Double Asteroid Redirection Test, and it was NASA's attempt to nudge a small asteroid moon, Dimorphos, into a slightly different orbit around the asteroid it's gravitationally bound to, Didymos. And the purpose of the mission was to demonstrate the kinetic impact of technology, a first step in asteroid deflection tests that may one day, like you say, save Earth from a devastating collision, the likes of which gave the dinosaurs something to think about, albeit briefly.
Yeah, absolutely. It's interesting to read why Dimorphos was selected as a target. Apparently, they're a safe distance away from the Earth, so anything that we do to it is not going to nudge it in our direction. The pair are actually an eclipsing binary when viewed from the Earth. So astronomers on our planet can measure the regularity of their mutual eclipses and see the difference in brightness. So we know exactly how long it takes for the moon of Didymos, Dimorphos, to do a rotation. It's quite slow, but we can see exactly how long it takes to do an orbit. Now, it wouldn't be interesting if we could actually send a rocket up there and impact that small moon, which is about the same size as the pyramid in Giza. If we can hit that at a high speed and nudge it in its orbit around its parent body and see if we can actually get it spinning in a faster orbit to see if we can nudge it. Now, if we can do that, then we've got a good chance of nudging another asteroid which is on a collision course with planet Earth. Now, the collision was at 10.6 million kilometers away, so that's a heck of a long way from Earth, and we had to launch this rocket and aim it at a small object which is orbiting another object, and it's only 170 meters in diameter. So to actually hit the moon and not hit the parent body or miss altogether, there was a lot hanging on this mission. So what did you think to that, Joe?
Well, it's incredible. I mean, it took 10 months to get there in the first place, which is a long way if you think about it's got to match an orbit and find this asteroid, and then it's got to redirect itself to hit its moon. It kind of blows your mind to think how do you
Yes.
how do you go about doing that?
Well, I know there was some fancy, yeah, there's some fancy particular cameras on board the missile itself. You could call it a missile or this lump that's going to hit Dimorphos. But
Yep.
the software as well, making use of the camera, actually locked on to the orbiting moon, this small moon, and all the way on that journey, it was heading straight for the moon, and it's traveling at it's traveling at 3.8 miles a second, 6.1 kilometers per second when it actually hit it. So it's going at a terrific speed, and to actually lock itself onto it and send photos back to us as it's encroaching on it, right up to the a few seconds before impact. That's quite incredible, really. And we can measure the result itself, and we could see the result. Both the
Yeah.
Webb and Hubble telescopes were looking at it, and other telescopes were looking at it to see what the ejector was from that planet and what the effect was.
So we could see the result because it was well, we could see it because you said it was an ecliptic binary.
Yes, it was. Yeah.
What does that mean?
So what's happening is basically because it's like a double asteroid. One's the Didymos and Dimorphos, right? They're a binary system, and in fact, Didymos, the major object, is a 16th magnitude. It's 780 meters wide, and that orbits the sun every 2.1 years. Now, Dimorphos is a moon of Didymos, right? And that's only 170 meters in diameter. Like I said, it's about the size of a pyramid. So these two objects are orbiting slightly each other. So from our angle on the Earth, when you look at them both, they're normally separate objects. But as the two objects come into view from us, as they intersect, then the brightness changes. So and as the moon goes around the other side, it goes behind the larger asteroid, then it dims. So we can measure how long it takes to see this dimming and brightness process and work out exactly what the orbit is. Now, prior to Dart's impact, it took Dimorphos 11 hours and 55 minutes to order Didymos. Now, after the crash, to be honest, what the NASA defined as a minimum successful orbit period change, they are expected at least a minute and 13 seconds change to that particular orbit, which we can still witness from Earth. But actually, the orbit has been reduced by a whole 32 minutes. So from 11 hours 55 minutes down to 11 hours and 23 minutes. So it's been a huge success. And what we've done really, we've bumped into that little asteroid and really sped it up and proved the technology of locking onto it and traveling all that distance in space, and proved, I mean, it's physics at the end of the day. We've got a
Yeah.
larger body being hit by a smaller body, and the actual the aircraft itself was only about 1,260 pounds or 570 kilograms at impact, but it was going at a heck of a speed, like we said before, 3.8 miles per second. So it's whammed into that little asteroid and gave it a really good kick. Now, okay, if we've got some large asteroid traveling towards Earth and we need to give it a nudge, we need to nudge it early on, because a small nudge, when it's a long way away, will hopefully deflect it away from hitting Earth if it can be proved that it's going to happen. So, yeah, and I read in astronomy now that these results weren't known, but on the web the information is there straight away, and it's been a huge success, and they've proved that this orbit has been changed. So it's just amazing, really.
So the orbit's changed, and as you said, the orbiting time has gone down from 11 hours and 55 minutes to 11 hours and 23 minutes, I
Yeah.
think. And DART, what happened there was DART, it flew into Dimorphos head on, pushing its force in the opposite direction that it's travelled. Is that right?
Yes. It hit it from behind. It gave it an extra shove.
So aiming to slow it down, reduce its momentum, and reducing its orbit, bringing the moon closer to the parent asteroid, therefore reducing its orbital period.
Yeah.
Is that right?
Yeah.
Yes.
So success. They've proved that they can hit an object from a long distance away. They proved they can get it there. I mean, I don't know if they've got any spacecraft on hand that they can just say, well, let's launch another one at a moment's notice. But most of these asteroids, we've got thousands of them up there. We've got near Earth objects. We know most of them. We don't know them all. It would be nice to think that if we did realise that an object is hurtling towards the Earth, or it's in our path at some point, that we could have the time to get a spacecraft to make a rendezvous with it and to give it that kick to get it out of our way. But that is it's a watershed moment for planetary defence, really, and we've seen it on movies. Normally it's the last second. They're blowing up a comet or an asteroid just before it hits the Earth.
They usually blow up one problem into many problems, don't they? They're usually in those films.
Exactly.
But there was another probe accompanying DART, LYSEA-CUBE, which stands for the Light Italian CubeSat for Imaging Asteroids, and it accompanied DART along the way, took pictures of the approach, the impact, and the aftermath. And obviously, that we can tell the orbit has changed from Earth, but they're going to be doing analysis that's going to be ongoing for a lot of time using the footage. One factor they attribute the overwhelming success to is the ejection of tons of material from the asteroid due to the impact. They think this may have caused a recoil, kind of enhancing the effect of DART's impact. So a lot of work will go into understanding the efficiency of the energy transfer as well. Like you say, it's all physics. This should give them better insights on how they may upscale or downscale the mission for future uses, and also how did the structure of the asteroid itself affect the outcome of the experiment. And I think that's one of the things that the LYSEA-CUBE's gonna help with, because you would think that not all asteroids have got the same surface densities. So if it's hitting something more solid, like a big, if it was a granite slab, it would have a different effect than if it was just some loosely packed gravel, wouldn't it? So
that's right. I mean, the tail, the ejector from the asteroid has been spread over thousands of kilometers into space, and the spectra of that is being examined. They are going to launch another craft called Hera, HERA, which is going to be a follow-up mission. That's going to visit the Didymos Dimorphos system in 2026 to observe the crater and any other long-lasting effects from the impact, such as landslides or even a change in the shape of Dimorphos, and to conduct general science, including determining the composition and bulk structure of Didymos and Dimorphos. So we do know a little bit more about them. A few minutes, well, sometime before the impact, there was an item called Draco. It was a small, like, camera system and with a small aerial. It was detached from the main DART, and it had been following the DART, so it could actually witness the impact and look at the crater as it sped by. It was about 5 minutes before, but we're waiting for that data to come back as well. I've not heard anything about that one yet. But that small CubeSat was going to take a photo of the crater and then slowly send it back to Earth to see what happened. I've not seen a report on that, but there's going to be lots of follow-up work done on this, so we can learn about what to do next time.
Well, yeah, it's a really exciting mission, and the whole point obviously was to test if we can shift an asteroid away from an Earthbound trajectory. But not only do we have to find a problematic asteroid, we have to find it early enough to launch a defense. If we see it early enough, well, I say the earlier we see it and spot it, and the quicker we can get out to it further away, the smaller the impact will be needed to kind of drastically change its course and divert it a long way away from us.
I'm pretty sure there's some very clever people thinking about all this. I mean, it may be necessary to send more than one rocket at a time just to make sure you have some success if it's really a serious event. But it's good to think that somebody is working all this out.
I heard one option that has obviously not been done or tested, but one I heard being discussed was just painting one side of it white, and the different energy absorption from the sun over a long enough period of time would divert one way or the other. So, but the chances of needing an asteroid diversion mission are very slim at the moment. However, it's better to have a defense and not need it than to realize one day we need it and not to have it there ready to go. So that's why we're working on this.
Yeah.
I say we. I'm not heavily involved with the Dark mission myself. I mean NASA. We as a species.
The other thing is, it's like comets. You know, some comets have got 10,000, 100,000 year orbit. They're coming from way out there in the Oort cloud, etc. So we're not quite sure when something's going to come. So we need to be ready for it.
Yeah, NASA do search a lot, don't they?
We just got to look after this planet. This is the only place we've got, so we've got to look after it a bit better than we are doing.
Yeah, and NASA do have a program called Sentry that tracks objects that may be a threat to us in the future. Near-Earth objects, or NEOs, as people call them, are tracked down to about the size of a cricket ball. Is the analogy I've seen, and the highest risk object they have in their sights now is an asteroid that's it's a massive 2 meters wide and has a whopping 2.5% chance of hitting us sometime in the 2080s. So we might be okay for a bit. Saying that though, we probably only know about 40% of the NEOs that are more than 140 meters inside, according to some models. So there's a larger proportion, 60%, estimated to yet be found and tracked. So there's a small chance that some asteroid in that 60% may catch us off guard. The issue with objects in space, though, is we're finding them is that they're notoriously dark, and space is dark, and it's hard to spot them. Still, the odds are very small, and there's no need to worry. And now the space sector is on the case, just in case. So, like you said, it's good that there's people out there who are very smart and very driven and are doing this.
Absolutely. Yeah, fingers crossed that we get this system all ready for the next one.
Yep, and as you say, neither Didymos or Dimorphos posed any threat to Earth before, and they still don't.
I must say, I'd never heard of these two before. There's thousands of them up there, so
neither have I actually. I remember hearing them talk about Dimorphos, and it had a nickname Didymoon because it was Didymos's moon. And it was a small one. I quite like that nickname. It was easier to remember. Right.
Yeah,
well, thank you very much. I think we should take a quick break and then come back and talk about what's coming up in the sky for November.
Okay, thanks, Joe.
Sequence start. 6, 5, 4, 3.
So it's November, and yet again we're wondering what is going to be up in the sky for us to find this month. And luckily, Steve is still here to let us know his top picks for November for members and non-members of MSAS to have a look at. So, Steve, where would you like to start this month?
Well, I'd just like to say that this is a great time of year. I love the spring because we can see spring galaxies and stuff like this. There's some favourites there. But at this time of year, we've got dark right from tea time all the way through till the following morning. So we've got more opportunities to see stuff in a comfortable hour, mostly, unless it's a particular thing you want to see. So I like it in November. It's getting colder, but there's plenty of stuff to see, and we've got a promise of some lovely stuff coming up from Orion and stuff like this. So November's a great time.
I always think when people complain about the cold in November, there's no such thing as the wrong weather. It's just wrong clothing.
Or not enough clothing. Yeah, absolutely.
It's only cold because you're not wearing enough.
I mean, okay, it's lovely in the summer to go outside with, shorts and everything else, but you don't get much dark,
No.
Enough to see stuff. So, yeah, I look forward to November skies. And we're lucky at this time of year because every 2 years and 2 months, we get Mars come into opposition when it's the closest to us. It won't be as close this time as it was last time, but it's going to be a worthy object to get in there, to get in the eyepiece, because, yeah, Mars is a fabulous sight, and it's in Taurus this month. That's where the Hyades and the Pleiades and stuff like that. It's in that general area. But it's going to be the best over the next 6 or 7 weeks than it's going to be over the next 2 years and 2 months till it comes around again. So it's going to be at the closest.
And that's due to its orbit in relation to us, isn't it? It's closer to us at those periods.
Yeah, we have gone round the sun and we're at our closest to Mars. Mars it takes longer for it to go around the sun, but we're caught it up again. It's moving. We're moving on the inside of it, but it's at its closest to us. So it appears bigger in the sky. And because it's bigger, we can get our telescopes on it and we can see detail. Now, this is really worth doing. I mean, a couple of years ago, there was dust storms on Mars. The features were blurred. It was like a non-event, really. And they have to wait another 2 years, 2 months till it comes round again. And this time, the 2 years and 2 months means it's going to be happening in December when it's at the closest. But now it's getting big. It's getting closer. You can see it over in the east in the evening. Jupiter's straight up. Mars is over to the left there on the ecliptic, but it's coming up. And during the night, it's climbing higher and higher. So this is the opportunity for the next 6 or 7 weeks to get your scopes on it and try and tease some detail out. Now, a few years ago, I had some stunning views of Mars. You could see the light and dark areas on it. You could see the polar caps. And with some filters, you could actually tease out some detail, more detail, the differences between the light and dark. And you could even see, perhaps, maybe in my mind, but you can see clouds on the planet as well. So this is the opportunity to get some Mars in. It's not going to come round for another couple of years.
So it's getting higher in the sky and it's getting bigger. What feature of Mars do you recommend people try to find at home?
Good question. Things like Syrtis Major, it's the difference between the when you look at it, you can see light and dark areas. I'm not saying you're going to see Olympus Mons or anything like that, or Marineris or things like this, but the thing is, you can actually see details on the planet. Now, normally Mars is that far away. It's just a tiny dot, about the same size as Uranus or something like this. So you can't see any detail on it, but this is the opportunity. You don't know what you quite can see. If your seeing conditions are good, if there's no moon, if everything's honky-dory, and even just using a couple of filters like a red filter or a blue filter, you can then tease out these differences by blocking out certain wavelengths of light. You can actually see better contrast between some of the areas. You can see the polar areas better.
Okay.
You can see the difference between the light and dark. So all you need to do is look at it through an eyepiece, get it on an eye magnification, and just slip a filter like a blue 80A type filter in front of your eye between you and the lens, and then move it away and just keep doing that and see if it makes a difference. If it doesn't, try a red filter or try them both together. All you're doing is blocking out certain wavelengths, but it enhances the light that you want to see coming through. So it's worth trying it. The thing is, and it's not going to be there for an event. Like last week, we witnessed the partial eclipse of the sun by the moon, and it was great. I was on that for a couple of hours last week, and it was fantastic. But it's over and done in a couple of hours. Mars is going to be up there for weeks, but once it's gone, it's gone. It's like Saturn now. Saturn's been up there, but now it's heading towards the horizon, and we can say virtually goodbye to that, because by the time it gets dark, it's slipping towards the horizon. It's too much atmosphere to look through.
Yeah.
So Mars is up there. Try and see it. If you can see it, if you can write a little bit of a report about it or take some photos, send them into the EH or try and share it with your fellow astronomers. We'd love to see stuff like this.
Yeah.
So, yeah. So Mars is a biggie. That is going to be there. Make the most of it.
It's Mars season. I'm saying goodbye to Saturn season and hello to Mars season for now.
Yeah, Mars is the big event for me. I'm really looking forward to it. I went down to the astronomy show the other day to buy an 8TA filter so I could tease out some more information from it. Couldn't get one down there. Came away disappointed. Went in my case the other day to clean my lenses up, and I've got one. So I'm ready for it. And so I'm looking forward to trying that.
Okay, excellent.
Okay, so talking about planets, up there as well, bright as anything, you can't miss it. Swing your scope onto Jupiter. There's lots of action going on there. It's got a fast rotation. The moons are always changing. Last Wednesday night, not the 10 days ago, we were up at the observatory, and I wrote about this in last month's Event Horizon about a particular night when, if you look at Jupiter, you'll only see one moon, because two of the moons are on the face of Jupiter and one is being occulted by it. And that was happening while we was up at the OBS a week last Wednesday, and some of the members up there and myself, we actually swung the scope onto Jupiter and we managed to see it happening. And everything as predicted in these programs that we look at, like Sky Safari Pro, everything came right. We watched Ganymede leave the face of the Jupiter. We watched the moon shadows transit across it, and it was all happening. It's all real, moving space stuff. It's happening as you're watching it. It's great stuff.
That's incredible.
And there's lots more going to happen with Jupiter as well over the next few weeks during November. Lots of action, lots of moon action, transits, etc. So yeah, it's another easy target, and a small scope. I mean, a medium-sized scope will show you lots of detail and show you moon shadows. Well worth looking at.
It's always amazing looking for the banding on Jupiter if you can get it.
Absolutely. And when we was looking at the moons on that particular night, the great red spot was also transiting across the face of the planet as well, so we could see that action as well.
Amazing.
It's amazing just to see things moving in space. We're not used to it.
Yeah. It makes it all real when you see something like that. You can look up and see these dots, but it brings them into real life.
It does. It's a wow. It gives you a wow.
So any more planets for us this month?
Well, interestingly, Uranus is coming to opposition on the 9th of November. And all these details we're talking about now are in the EH in more detail, but just a reminder that Uranus is coming to opposition on the 9th of November. So it's at its year's best.
Okay.
And it's almost naked eye, actually, Uranus is. It's got a magnitude of about plus 5.6. So on a good seeing night, some people can actually see it, but they may not realise they're looking at the planet. But through a small scope, you can see it as a disk. It's not a twinkling star, and it has got a small disk there, although you'll not see any details on it.
So what kind of equipment will an amateur astronomer be best to use to find Uranus?
Well, binoculars will do it.
Yeah.
If you know where to look for it, you can use your binoculars. Everything's the same view up. So if you know where it is, Uranus is between Mars and Jupiter, basically. It's to the right of the Pleiades at the moment, on the ecliptic line. So, but if you look at an app like Sky Safari Pro, or there's several out there, you can determine where it is and look at the stars around it, and then look at it through binoculars or a small scope, and then you should be able to identify this bluish greenish disk.
Brilliant. And you said it would be magnitude. Did you say 5.6 magnitude?
Yeah, it is around 5.6.
Am I right in saying that the higher the magnitude, it's actually dimmer?
Yeah. But the magnitude system's based on it's an old system. It's not very accurate, and and it's woefully lacking in a lot of respects. But basically, what they're saying is a really bright star like Sirius or something like that. That means slightly, it's near one, or it's just less than one, or
Okay.
it's very bright.
Yeah.
Right. And the faintest objects you can normally see with the naked eye is around 6. So if something's around 6 magnitude, +6, not -6. I mean, the sun is about -26.
Yeah.
Right. So the magnitude system is not like ×1, ×2, or anything like that.
Yeah.
It's about 2 point something times brighter every time you go up a level.
Yeah.
But if you're looking at Venus, it's about it can be -4 or 5. But most bright stars, the brightest stars, are based on magnitude 1. The faintest looking stars that you can possibly see are about magnitude 6. So if I said Uranus is about 5.6, if you've got good eyesight, you may be able to see it, although you wouldn't be able to say, oh, that's a planet.
Okay.
You need binoculars or a telescope to see it.
Okay. Excellent. Thank you very much.
Yeah, and it's not all that wonderful to see, to be honest. But the thing is, at least you've seen
Yes,
it.
you
know?
can tick it off the list once you've done it, off your
You can tick
viewing
it off the list. Yeah. So yeah, again, there's some more meteor showers this month. There's only one that's really going to be really good. That's the Northern Taurids meteor shower. That's around the 13th of November, when you might get some really slow meteors. You might get some bolides or some really bright objects going across the sky. Not fantastic. It's there. If you've got the opportunity to go outside and have a look, then do so.
Am I right in thinking that that's at some ungodly hour as well, that one peak? Is that
5 o'clock? 5 o'clock it peaks, but it doesn't mean you can't see some.
Yeah.
In the late evening. It's just that the area that it comes from, or the radiant, is below the horizon. So you might see a few shooting above you, but to see the whole thing, you need to be up around 5 a.m. But not many people are that dedicated to see it.
The 13th is a Sunday, so you could just do an all-nighter on Saturday and stay up as they get better and better.
Well, we've done it before, but mostly you've got other things to see as well.
Yeah.
But yeah, it's a tough one. Some people are dedicated. I'm afraid that's quite early in the morning to see the whole of it up there in the sky.
Yeah, definitely.
But I mean, if you go outside and you look up, and it's about 11 o'clock at night, and you look over to the east, you can see what's coming around. That stuff over there will be right above you in 5-6 weeks' time.
Yeah.
So you can see the Hyades up there, which is with Aldebaran, they're shining brightly in the V shape of the bull's horns and face, and to the right of it you can see the Pleiades. Now they're over there at the moment, but in the morning, if you're up 2 or 3 hours, they swing over above you.
Yeah.
And you can see them. And Orion's up there at 3 o'clock in the morning at the moment. Orion is up there. You can see Orion Nebula. You can see Sirius as well, which the belt stars are pointing down to. So, but they are going to be more comfortably viewed in December. So, because we're on our way around the sun.
Yeah.
So we'll get a better window of opportunity in December to see stuff like that. But if you want to step up late, or if you are up late, you can view it now. So there's stuff up there. But I tend to write a bit of a report in the EH about stuff you can see up to about midnight, around the midnight area.
Yeah.
I don't expect people to get up at 3 o'clock and see something unless it were really special.
Plus, if you did from 9 p.m. till early hours in the morning, it would be about 4 times as big, wouldn't it? Your job of everything you can cover in one night.
It would. I mean, I'm just giving a snapshot of what's due south at midnight in the middle of the month. So in November, at the middle of the month, I've put a big, printout at the back end of my report, which just shows you the southern window. There's stuff going off on the north as well, east and west, depending where you look. But I'm just giving you that window, and to be a different window every month because we're on our way around the sun. So we see when it's night time in the winter here, in the summer, you're seeing a different view altogether.
Yeah.
You're seeing stuff that you can't see now, because it's up there during the daytime,
Have you got anything else for us?
Yeah, I'd like to mention two quick things.
Yep.
First of all, I wrote about the Crab Nebula because I found it a fascinating phenomena, really. In 1054, there was a massive supernova, and we didn't have the capabilities to record those here over in the West. But it was a massive supernova, and it lit up the skies. You could see it during daylight. The Chinese recorded it, and other nationalities recorded it. But that supernova event has evolved over the last nearly 1,000 years into a supernova remnant now, which you can see. And Lord Rosse in Ireland named it the Crab Nebula because when he sketched it using his 36-inch telescope, he thought it looked a bit like a crab.
Okay.
So that name is stuck. Now, also, Charles Messier put that in his famous list of 110 objects as Messier 1, M1. Now, so that, to me, is quite an important little thing. And I can remember when I was in my 20s, I got a 6-inch reflector telescope, and I spent 2.5 hours trying to find the crab ones.
Yeah.
And it took me that long, but when I did find it, I was awestruck. And it's one of the I can see it now, and it's nearly 40, 50 years ago. And when I was looking at it through my little tiny eyepiece, and this 6-inch scope, it looked like I was looking into a pail of water, and there's a tiny little spot of milk hanging in the middle of the water of bucket, and it just glowing. And I could see it that's the first time. I can see it now in my mind's eye, and that's a wow I got from seeing the crab the first time myself.
Yeah.
I've seen it many times since, and it's awesome.
Yeah.
So I've made a mention of it because I think if you can get a wow from looking at stuff, that's what it's all about for me. So,
well, it's definitely something to look out for. And you mentioned there Charles Messier and his objects.
Yeah, Charles Messier, an interesting character. He was around. He was born in 1730 and he died in 1817. And basically, he was born to a wealthy family. But the thing is, he became a comet hunter. A lot of people back then were interested in finding comets. They didn't know what the nebula were. They didn't know what galaxies were. They thought everything was part of the same universe that is our galaxy, but obviously will be no different now. Some of the things are in our galaxy, and a lot of objects that's in the Messier list could be galaxies. They could be planetary nebula, like the Crab Nebula. But basically, he was a comet hunter, and he and his friends would send him information about an object while they're hunting for comets. And he determined a list of 110 objects to avoid, basically. And the list itself was made to distinguish between permanent and transient objects. A permanent object like M27, which is a dumbbell nebula, or M1, the Crab Nebula, M32, M110, and M31, which is part of the Andromeda Spiral Galaxy system. But a comet doesn't stay stationary. All these are permanent things. A comet is a transient thing. So he's looking for transient things. So he made a list of things to avoid. So if you're swinging your scope on something, you know that object isn't a comet because you know what it is. So this list of things to avoid is stuff that us common garden astronomers these days love to see. All the Messier objects, there's galaxies, there's nebula, there's globular clusters, and they're our favourite objects, and we call them Messier objects, M1, Messier 1, etc. And that's what it's all about, basically.
I find it incredible that he was looking for comets and meanwhile was finding all these other incredible, amazing things that he didn't understand what they were, and the comets that would interest us now, but nowhere near as much as all the objects that he discarded at the time.
Exactly.
Because he didn't want to be distracted by the same ones again. And we've ended up with a very useful, extensive list of some of the most interesting things in the night sky.
Absolutely. But like me, with the Crab Nebula, that fascinated me and got me deeper into astronomy, there was a comet in 1744. It had about 6 tails. And that comet, plus an annular eclipse in 1748, really hooked him into astronomy and got him interested in astronomy. And that's how he came to love the things that he was doing. So it was actually a comet that he saw from his hometown, by Don Villiers, I believe it's called. But anyway, it's just an interesting character, and we hear about Messier all the time. So there's a lot of it's only 110 things, but when you look at them, there's quite an extensive list. And just as famous are a lot of things that's not on that list.
Yeah.
They should be on it. There's quite a few things. It's just as bright. But it's good. It's a good thing to start and follow the Messier list.
A lot of people use it as a guide of things to see, don't they? They like to work their way through the Messier list.
Yeah. They're achievable objects.
Yeah.
Some of them are quite boring. They're just a couple of stars, but some of them are really good. Have you got time for another one?
Yeah, you can give us one more. Go on.
All right, then. Right. Well, this is an interesting one that I glimpse at. In Perseus, there's a triple star system. It's a star we call Algol, and it's got an interesting phenomenon going on. Basically, the large, bright primary star is regularly eclipsed by its dimmer secondary companion star. Now, we were talking about the dark mission at one point, and in that we said that it's an eclipsing binary.
Yeah.
Well, this star system is an eclipsing binary as well, and the stars are rotating around her quite quickly. It's every 2 days and 20 hours and 49 minutes, then a eclipse takes place. Now that causes a noticeable dip in Algol's brightness, and if you're outside, the magnitude can drop from, say, plus 2.1 to magnitude plus 3.4, and then that's roughly a whole magnitude.
Yeah.
And it can last for 10-hour periods. So when you do go outside and you're looking, and the Algo's up there in the sky, if you have a look at it and determine that it's dimmer or brighter than normal, then you could be actually witnessing this binary star eclipsing itself, and either being in that 10-hour dip, or in the period when it's at its brightest, when it's not eclipsed.
So that dip in magnitude is something you can see with the naked eye. Then you can just go and view that. And
well, you get used to it when you're looking at stars and you realise how faint they are, and you think, well, that's about a magnitude 5 or 6. This one's a 2, and that one's a 3, because you can see it's a whole lot dimmer. And that Algol itself, it's quite a prominent star when it's bright, but when it dims a whole magnitude and more, it noticeably is dimmer. It's like Betelgeuse looked dimmer about a year ago when we had a problem with that. So astronomers, it's not easy, but if you look at it often enough, you might think that looks dimmer than normal. And if you did look at the cycle, you might think, oh, I've seen that while it was in eclipse, eclipsed by itself, by its companion. So that's just a couple of things I think fascinating, really, because it's two stars rotating around each other, and we can see it happening.
It's very popular as well, isn't it? Well, I say popular, it's not like we demand it. It's very common in binary systems. We're finding them much more common than we used to believe. Yeah,
absolutely. There's more binary systems and triple star systems. I mean, it's like in Lyra, there's the double. I'll talk about that another time. But that's a double. The double is actually a star just off to the east or left of Vega, and the double itself, you can see it through a pair of binoculars. That'll resolve it into 2 stars. But if you really ramped the power up, and I'm not saying I've done it, been able to do it myself. I don't know if it's actually 2 binary systems, all rotating around each other. So you've got 2 pairs rotating around each other, and the pairs are rotating around each other. There was all made out of the same cloud, and they all formed at the same time, and that's known as the double. I think it's Epsilon Lyrae in Lyra, off the top of my head. But that's another one. Just bring your binoculars around to it. You can see it's a double. Get a big telescope on it, and you can see it's 2 doubles, all part of the same system. So
that's some serious gravitational balancing.
I'm not really one for looking at stars much, but they have the odd fascination. There's some people seek doubles out all the time, and the difference in colours.
Yeah,
it's I'll chuck this one as well. In Cygnus, the Swan, Albireo, it's a double. You can put your binoculars on it or a telescope on it, and it's a beautiful blue, and one star is blue and one star is yellow, and it's instantly obvious it's a double. So that's another double star you can look at. It's beautiful to look at. Everybody looks at it in Cygnus.
Excellent. So people need to go look out for their doubles and their doubles.
Yeah.
Right.
It's all good stuff. It's all good stuff.
Well, thank you very much.
Okay.
It's been another really good episode. I've really enjoyed it, and we've got lots and lots to get on with and to go and find before you give us another list next month.
Okay.
Thank you very much.
Thank you for that. Thank you for inviting me, Joe. Thanks.
Well, thank you very much for coming, and I'll see you soon.
Bye.
Thank you for listening to this month's Obscast. Here are a few notable dates for you coming up in November. On Saturday the 12th, we have an open evening, and volunteers are still needed for that, so please get in touch with Brendan Schooler. And on the 29th, we have Dr. Jennifer Millard coming in to give a talk about galaxies and infrared astronomy. The open evening on the 12th is open to the public if you book ahead of time, and the talk on the 29th is for MSAS members. Thank you very much for listening, and we will see you next month for December's Obscast.